Hello, my name is Pedro Machado, and I'm here to present the PerceptionBlade project. So the AU Directive 2009/128/AC sets environmental goals for sustainable use of plant protection products or pesticides. AU countries must design national action plans to reduce the quantity of pesticides used. Back in 2016, the Eurostat reported that Spain led pesticide sales with about 78 millions of kilograms, followed by France that consumed about 72 millions of kilograms of pesticides as well. In the overall, about 400 millions were spent by the EU countries for buying pesticides back in 2016. In the latest 2020 report, it is stated that more than 2/3 of the member states failed to complete the review their initial NAPs, and only a minority of member states managed to propose clear targets/indicators for reviewing NAPs. There will be drastic changes in the way that pesticides are used, and new measures will be enforced by the EU countries for the sustainable use of pesticides. Sundance is a 30-year hardware company that has recently refocused the business plan in agri-food solutions. Emerging RAS solutions demand high-performance and low-power heterogeneous edge computing platforms capable to process in real time and at the edge high volume of data captured from state-of-the-art devices. The Vine Scout project, Horizon 2020 program under grant agreement number 737669 enables Sundance to design the VCS1 system, a high-performance and low-power heterogeneous edge computing platform at the TRL-8 level. Furthermore, the Field Companion project, EU Eurostat agreement number 11884, extended the capabilities of the VCS1 system and enabled Sundance to develop the IP perception model called ICS, also known as image control system, for the autonomous control of the spraying system, and reached the TRL 7 level. The ICS system controls nozzles arrays using state-of-the-art artificial intelligence algorithms. So the PerceptionBlade objective is to integrate the VCS1 and ICS system into a plug-and-play, safe, efficient, and easy to integrate TRL-8 solution to be integrated with existing or new spraying system. The Perception aims to provide the desirable hardware-software abstraction, enable potential users such as roboticists, computer scientists, embedded software developers, OEM integrators, and others to integrate the PerceptionBlade solution in their application. The PerceptionBlade solution is an integration of the VCS1 system and the ICS system, which are at the TRL7 level. The TRL8 is only possible by thoroughly test the PerceptionBlade in well-designed use case scenarios covering both aerial and terrestrial platforms and in different crops. The PerceptionBlade will be running ROS/ROS2, and therefore the Sundance team will have to engage with Atlas teams to create a ROS-Atlas bridge and make sure that we are able to integrate both systems. Furthermore, the PerceptionBlade targets, as I mentioned before, OEM integrators, roboticists, software developers, and computer scientists, and not the final users itself. Well, the PerceptionBlade delivers a high-efficient solution using state-of-the-art AI algorithms accelerated in the heterogeneous edge computing platform. The PerceptionBlade solution is a high-performance system capable of processing RGBD, also known as depth and color images, and near infrared at 30 frames per second from both left and right vision devices. The captured vision data is used to extract features and trigger automatic responses for the controlling the spray nozzles. Also, humans and animal detection and further states of the plantation. In summary, the PerceptionBlade solution will deliver ready-to-use, low-power and high-performance solution to be integrated with the traditional / new generation of autonomous sprayers for autonomous control of the spray nozzles based on the visual perception system and significantly reduce of the quantity of pesticides to be sprayed. The PerceptionBlade is being designed for supporting the sustainability use of pesticides and autonomously adjusting the spraying flow. Furthermore, the PerceptionBlade is designed for fulfilling the requirements of Topic 1 within pest control and particularly Topic 2 irrigation by making it possible to irrigate using the spray system and contribute to Topic 6 information platform for farmers by collecting relevant information to be offloaded to the cloud when internet connection is detected. The proposed architecture has been tested under laboratory conditions and must be tested in the field. Okay, this is something that we need to do. The PerceptionBlade solution is currently at the TRL 667, and the validation tests will push it to the TRL 8. Sundance commits to deliver an intelligent system to be installed on terrestrial aerial spraying platforms capable to reduce by at least 20% of the amount of pesticides to be sprayed in the field. Sundance aims to partner up with Atlas partners and benchmark traditional spraying systems and robotic autonomous systems fitted with the PerceptionBlade system. Despite Sundance can provide support to Atlas partners interested in adopting the PerceptionBlade, Sundance will not allocate resources to develop, implement software on the sprayer side, and this is the main reason why we are not targeting the TRL 9 and we are targeting the TRL 8. The PerceptionBlade will be validated using data collected from 3 test use cases on advanced statistical analysis tool that will calculate and quantify the pesticides that will be used to spray the target crops and compare it with the quantity used by traditional systems to spray the same crops under the same conditions. The PerceptionBlade will contribute directly to the reduction of pesticides used in farming, contribute to the precision farming by collecting relevant details about the plantation and increase the safety for both humans and animals through the safety awareness model that prevents the sprayer to spray when humans and animals are detected. Okay, so the PerceptionBlade solution will be integrated with the Atlas ecosystem, validated using data acquired in the field. Furthermore, the PerceptionBlade will be thoroughly tested in the validation tests, which will be designed to demonstrate that the proposed system is fully integrated with the Atlas ecosystem. The PerceptionBlade will contribute to the following Atlas WPs. So WP5 machine and sensor intercommunication installed integrated into participant machines. These are one of our objectives. We do not know if the WP5 will be possible because, as I pointed out before, we need someone from the other side to develop the interface to interact with PerceptionBlade. Again, it's one of our objectives. WP4 data acquisition and analysis service collect pre-processed data in the field to be uploaded to the cloud. Again, we are going to demonstrate this using the PerceptionBlade. WP7 system integration and testing. The PerceptionBlade solution which is already at the TRL 7 and needs to be validated in different use cases for reaching TRL 8, and WP9 standardization and business sustainability. The PerceptionBlade is the combination of the outcomes of two other projects that follow standard interface, for example, Wi-Fi, Bluetooth Low Energy, 4G, and so on, and adopted the use of standard tools, example, ROS, MQTT, OPC, UA. Therefore, the PerceptionBlade can provide guidelines for the agriculture industry electronics foundation. The route to sales for Sundance is through established sprayer manufacturers, and we shall be contacting an external company to finding them all within the EU/UK. The PerceptionBlade will be in the market as an add-on in similar ways as the SatNav was 10 years ago. The initial target price for the farmers will be 7,000 to 9,500 euros. Will allow 15% margins to spray manufacturer and 50% to Sundance. The initial focus will be on verifying and validating of the benefits of a partial spraying of any crops, and with the successful use case and integration with the service like Atlas. Sundance can engage with the food and consumer industry. The pressure for farmers invest is such in such a technology come from the consumers, as otherwise food industry supermarkets will not react, and the spraying technology will not be added by manufacturers. The other important model of pressure will come from lobbying by environmentalists, and a successful use case is expected to create interest at the national level. The PerceptionBlade solution will be used in the precision farming, more especially in weed pest control and irrigation. Moreover, the PerceptionBlade will be compliant with industrial standards. So, as example, we have the ISO-BUS, and therefore is sustainable to be used in a worldwide market, but focus on the first 1 or 2 years will be through agreement with FEDE of Spain, followed by other EU, UK manufacturers. So FEDE is one of the world leaders in terms of pulverizers. They work directly in partnership with John Deere. We have, as we pointed out, we have FED and Sundance are partners in the Field Companion project. So FED has pre-agreement with Sundance and will be the main client / distributor in the worldwide sprayers market once the perception becomes close to commercialization, which is TRL 8, which is expected in 2021. The validation test will expose bugs and potential weakness, which will be promptly corrected. Sundance aims to find potential partnerships through the Atlas network. Cooperative robots, also known as cobots, is an emerging field which will demand the use of solutions such as the PerceptionBlade to process exchange data between multiple robots operating the same / different fields. The Precision Blade will be installed in FET sprayers and made available to the worldwide customers. Moreover, Sundance will be able to reduce the production cost, which is directly related with the price of the onboard Xilinx and PSOX chips. In parallel, Sundance will be adapting the Precision Blade to be used in other fields such as mining, infrastructure inspection, space, etc. The PerceptionBlade solution brings together the Sundance VCS system fitted with the cutting-edge Xilinx MP-SOC technology, bleeding-edge AI inference, Xilinx GTS framework, state-of-the-art AI algorithms powered by the robotics operating system. So the VCS system in Figure 2 is composed of two models. The top one that we can see here is called the FM191, and the second one on the bottom is called the EMC2. So the cutting-edge Xilinx EV MP SoC is composed of a powerful ARM Cortex-A53 processor for running a standard embedded Linux operating system and ROS. An ARM Cortex-R5 real-time processing unit for processing interruption in real time, an ARM Mali GPU for image processing, and a programmable logic for accelerated AI inference and computer vision algorithms. We also have a dual CAN installed on the FM191. Dual CAN buses interfaces, 1 gigabit Ethernet connection, Wi-Fi, GPS, GNSS, 4G Bluetooth Low Energy, 4 USB 3 interface, SPI, I2C, WART, audio interface, SATA port, a micro SD slot, HDMI port, and a 40-pin GPIO, which is compatible with Raspberry Pi. Now, the PerceptionBlade solution in Figure 2 includes a positioning and speed model for processing positional data captured from GPS and GNSS and tracking device, vision devices, interfaces compatible with the commercial off-the-shelf vision devices, actuators interface for interfacing with commercial off-the-shelf actuators using standard interfaces, cloud interface that enables to offload data collected in the field once the internet connection is detected. Semantic segmentation model is responsible to classify and map region of interest, which will be used by the other models. AI accelerator used to accelerate the object classification using a neuromorphic convolutional neural network. Computer vision accelerator used to accelerate classical computer vision algorithms, statistical analysis model for performing statistical analysis of plants and plantation, safety awareness model for detecting and protecting humans and animals from being sprayed, anomalies detection model for detecting anomalies in the plantation, vision speed estimation model for estimating the speed from the image and avoid overspraying the same regions of interest. Actuators control models to adjust the activation and regulation of the nozzles or group of nozzles, pumps, and motors. So our main goal is to make this the system compatible with both ROS and ISOBUS. We currently have the system integrated with ROS, and we'll be making effort to integrate with ISOBUS. Nevertheless, at this stage, we cannot commit that in the 6 months we will have the system 100% compatible with ISOBUS. The PerceptionBlade project includes the three main work activities: WA1, integration of the PerceptionBlade with the Atlas ecosystem; WA2, validation tests; and WP3's management and exploitation. The tasks and work activities are as follows. Okay, so we have task 1.1, preparing installation and service manuals, which are crucial so that the UAM integrators to install and provide support to the final users. Design 3 use cases for validating the system. The 3 use cases will be designed to validate PerceptionBlade in our aerial and terrestrial mobile platforms, and also with different plantations. Task 1.3, design and implement the human-animal awareness system. The AI algorithm will be trained on the classification of humans and animals and integrated with the humans and animals safety model that will stop the nozzle control array, while the human and animal is within the range of the sprayer. Then we have task 1.4, implement a ROS bridge to interface with the Atlas system. The PerceptionBlade will be running ROS and ROS2, and therefore it will be required to create a ROS bridge in order to interface with that system. Validation tests, the work activity 2. So task 2.1 aims to collect data from the 3 use cases. Data sets will be collected in each one of the 3 use cases. The data sets will contain details of each plantation type and also details about the field and details about the quantity sprayed and nozzles array configuration used by the traditional spraying system. Task 2.2, design and implement a statistical model to measure the quantity of liquid to be sprayed based on the nozzle array setup and the characteristics of the nozzles. The statistical model will be used to estimate the savings that will be achieved by using the PerceptionBlade using the same nozzles array configuration. Task 2.3, field tests phase 1. The PerceptionBlade will be tested during the FT1 according to the FT1 plan designed to expose both hardware and software bugs. Task 2.4 is the correction of software hardware bugs emerging from the FT1. Any bugs exposed during the FT1 will be corrected and new features will be incorporated. Task 2.5, validation of the test phase 2 and the integration with the Atlas ecosystem. The PerceptionBlade will be tested during the FT2 accordingly to the FT2 plan designed to expose and validate the system against the list of requirements. Correct and task 2.6 is the correction of software hardware bugs emerging from the FT2 fine-tuning on the PerceptionBlade solution to assure that the requirements are fulfilled. Then we have work activity 3, management and exploitation, which includes interim report, promote, and the task 3.1 promote the perception at the Smart Farming Conference in Düsseldorf, and the final report. So Sundance will engage with the Atlas network to expand the field test scenarios, search potential customers and partners and business opportunities. Simultaneous Sundance aims to use datasets for training the AI algorithms for enabling the PerceptionBlade to expand its functionalities. The PerceptionBlade will also be used to collect new datasets that could be added to the Atlas datasets collection. The VCS system or PerceptionBlade is being manufactured in compliance with the EU and UK regulation. So just to summarize our proposal, we aim to deliver the PerceptionBlade is a system that is being designed to be installed on spraying systems. Such sprayers could be completely autonomous platforms, or it can be machines already being used in the field. And the goal here is to be able to develop, deliver a system that can be easily integrated with such systems and allow the intelligent control of the nozzles. So the goal here is to actuate directly on the nose. We are confident that we'll be able to save at least 20% of the amount of chemical being sprayed in the field, and in specific situations, we may be able to achieve more than 20% of savings. I hope you enjoy. I'm happy to answer any questions that you may have, and thank you very much for your attention. And hopefully this proposal will be one of the winner the proposals being funded, and we are looking forward to work with the Atlas team. Thank you.